Okay, we do have this thing, a vertical cylinder. Uh, Read it. Let me have water. A vertical cylinder of cross-sectional area S contains 1 mole of an ideal monatomic gas under a piston of mass m. It's a tangent a heater which transmits to a gas an amount of heat Q per unit time. Means it will supply power continuously. It will supply heat per unit time. So that is what Q. There's nothing but power. Switcher on piston, determine the established velocity V of the piston under the condition that the gas pressure under the piston is constant and equal to P naught. And the gas under the piston is thermally insulated. Everything is insulated. So yes. So what is telling, it is going to move, it is going to ascend up with a velocity V. Okay, let's see what are the forces that will be acting. The weight of this. So here means it's asking to consider the effect of gravity also. Let me write G equal to 10 meter per second square. Here atmospheric pressure force and the pressure of gas PA. As it moves with a constant speed, so what do we expect? The pressure of gas will remain constant. You can see from the equation. PA minus P naught A minus mg equal to 0. The pressure of gas equal to P naught plus mg by A. The pressure of gas, it in fact remains constant. So therefore, what process the gas will undergo? Isobaric process. Okay, you should identify what process in fact the gas will undergo here. It's an isobaric process. Okay, then pressure equal to. Okay, let's see that. What is asking to get the speed of the, to get that speed V. Okay, let's go for first law of thermodynamics. So what first law of thermodynamics says, like what all heat supplied, a part of that is utilized to increase the intensity of the gas. Remaining will be converted into work done by the gas. So what is our expression? Q equal to, Q is equal to, or dq is equal to du plus dw. What is du? Du will be nr gamma minus 1 into dt. What is dw? Dw is pdv.
Sir,
Ah.
sir, in the question he gave something about that the condition that the gas pressure under the piston is constant and equal to P naught, sir.
No, no, no.
What does it mean, sir?
Okay, this is constant. You need not to say constant. Okay, that. And atmospheric pressure and the gas and the piston is thermally insulated. Okay, this. Okay, I'll strike it out. Determine the established velocity of the piston on condition that the gas pressure under the piston is constant. Okay, this. And the gas under the piston is thermally insulated. Okay, that one here. Okay, okay, fine. I just made changes.
Okay, sir.
Or pressure P you would have said. Instead that we know mass and pressure, no, let me express here, no. Okay, this is what the heat supplied by the heater coil. So what it does, a part of it heat is utilized to increase the intensity of gas. Remaining is what? Work done by the gas. Okay, this is what he's asking. He's asking to get that velocity V. How do I can bring velocity of the piston? That's what I'm trying to do here. Okay, no, next part. NR gamma minus 1 dt. What is the pressure of gas? We know it is P naught plus mg by A. What is dV? So shall we write A into dy because of the change in volume? Anyway, pressure is constant. Later on I'll introduce. So this will be P. So shall we write A into dy? Okay, let me differentiate this. So dq by dt, nr gamma minus 1. So this will be P naught A plus mg, because the A I'll send inside. So this will be dy by dt. The dy by dt and dq by dt is what? This is q. This is nr gamma minus 1. This is a general thinking what student will have. Okay, dy by dt is what? V. Okay, now what to do with the rate of change of temperature? We don't have any information, no? 1 mole is there. Okay, I'll replace that 1 mole. What to do with this dt? A student must think. It's not that something directly what happen, I'll go and write the answer. No, go back to first law of thermodynamics and analyze. So what is the biggest problem? We don't know this rate of change of temperature. We don't know this rate of change of temperature. Okay, as it is, what is the process? Isobaric process, no? Okay, let's write PV cotenant, pressure constant. Agree this? Therefore, in place of dt, what shall I write? P dV by nr, and pressure is constant. So I should have, what I should have done? I should have done that replacement here only, no? I should have done that replacement here only, so that I could have proceeded very easily. Getting this one, see, you have to think naturally what happens. This is what everyone will think. What to do this? Again, okay, ideal gas equation. See, that's what I'm telling. First law of thermodynamics, ideal gas equation, then take help of piston. That's what all these numericals are related here. Okay, let me replace this dt. Okay, this will be P dV dt is equal to, there's a volume, not velocity. I think velocity small letter I'm writing. So this will be nr dt. Substitute this here. So this will become q equal to nr gamma minus 1 p by nr dv by dt. This is p naught a. So what is dv by dt again? nr get cancelled. So q is equal to p gamma minus 1. dv is what you can write a dy by dt. P naught a, no? It is. This I just took some lengthy method. In the second equation only, we should have adjusted all here only, but it will not flash for you. Very rare will okay, let me replace these two here. We just proceed. Here what happen, will get stuck. Then I will get equation, then we do think. So just like a how students think is what I'm showing. So there's no need to be panic. That's what I mean to say here. PA, what is dv by dt? dy by dt is v. Okay, no. PA, what you can write? P naught A plus mg only. So this will become further. Q is equal to. Okay, now P naught A you can take outside. So how much we are getting? This Q is equal to P naught A plus mg gamma by gamma minus 1 into V. So expression for V will be Q gamma minus 1 by speed of piston. Slowly getting the idea. First law of thermodynamics, ideal gas equation, force acting on the pistons. Somewhere, this is what, in every numerical, we do think in this way only. Okay, no, so let me bring one simple, nice question.